Alright, so today we're going to solve systems of equations using the elimination method. Now you'll see in one of my previous videos I did the substitution method. So today we're going to do the elimination method. And I'm going to set up an equation for you in a second here. So elimination method. Our equation here now is going to be 3x plus 3y equals 15. And since you need two equations to do systems of equations, we're going to have 2x plus 6y. This is a plus. 2x plus 6y is equal to 22. Okay, so we have both of our equations here. Now, your goal for the elimination method is to eliminate one of the variables at first so that you can isolate and solve for one and then plug in the other, plug in the one you solve for to find the second variable. So the easiest one to solve here is, well, what do 3 and 2 have in common? How can I make these two the same but opposite? Well, it's a little harder to think about. So let's see the 3y and the 6y. Well, they both have a 3 in common. So if we need to get this 3 to make this 6, but this is already positive, that means we need to make this a negative 6. Well, how do we make this a negative 6y? Well, let's bring it over here. So what we're going to do is 3 times negative 2 gives us that negative 6y. So we're going to multiply this whole top equation, the whole thing. You have to include this solution here because it will not work out for your systems of equations if you don't multiply by the whole thing. So we're going to multiply the whole top equation, the 3x plus 3y equals 15, by this negative 2. Now you're using the distributive property here, so you're going to take this negative 2 on the outside and multiply it by everything on the inside individually. So let's do that. Negative 2 times 3x gives us negative 6x. This negative 2 times 3y gives us a negative 6y, which is what we're looking for. And then this negative 2 times 15 gives us a negative 30. So now that we have this second equation that we made from the original first one, we can move this equation over. We can bring this underneath, and when we're doing systems of equations, you're going to add these. So you have 2x plus 6y. And if you notice, this is the goal we are looking for. We are trying to get these to be opposites because these opposites are going to cancel out or eliminate each other. And now you bring the rest of your equation in, and you see here that negative 6x plus positive 2x is going to give us negative 4x. These are going to cancel out, so let me get red here. This negative 6y is going to cancel out with the 6y positive. So now we have no y's left, which was what we wanted. And now we have negative 30 plus 22. Negative 30 plus 22 is negative 8. Basic algebra states that this is multiplication. So we need to take the opposite of multiplication and divide. Divide by what to get x by itself? Well, divide by this negative 4. If we divide by this negative 4, algebra again says we have to do it to both sides of the equation. Let me get my red out again. This negative 4, since you're dividing by this negative 4, the goal is to get x by itself. So those 4's are going to cancel out. And now you'll have x by itself. So this is what we're looking for, to isolate one variable. And what's negative 8 divided by negative 4? Well, a negative divided by a negative gives us a positive. So 8 divided by 4 is 2. Here's one of our solutions right here. We have x is equal to 2. Now you can take this x equals 2, now that you've isolated and solved for one of the variables, you can plug it back into either of these equations and see what you get for y. So since we used the first equation on, for the distributive property to find a variable to eliminate, let's use the second one. So I'm going to bring it down here. I'm going to use a different color. I'm going to use orange. So I'm going to take this 2x, 2 times what we now know, x is 2, and add 6y and set it equal to 22. Doing this, 2 times 2 is 4 plus 6y equals 22. Now, just like we did in the top equation, we need to get y by itself now instead of x. We already solved for x. So if this is a positive 4, the opposite of addition, since it's a positive 4, we need to subtract 4 from both sides. If we subtract 4 from both sides, now we're left with these 4's again canceling out, and you're left with 6y is equal to 22 minus 4, which is 18. Again, basic algebra. I need y by itself. So I'm going to have to divide here, because to undo the multiplication. I'm going to divide by 6, because that helps me get the y by itself. And I'm going to do it to both sides of my equation. So once I see that these 6's cancel out, I'm now left with y is equal to, and I'm going to write it over here because I'm running out of room. Y is equal to, actually, you know what, let's back that up here. Let's see. I'm going to scroll down a little for a second here. All right, so now we see that we have y, and what is 18? Y is equal to, what is 18 divided by 6? 18 divided by 6 is 3. Okay, now we have an x value and we have a y value. So here, the system is going to be 2, 3 as an ordered pair, because this is your x value and this is your y value. Now let's plug both of these numbers in. Let's plug both of these in. Let's try that first equation again. Let me try green. Let me scroll back up as well. Let me see. So now we're going to pick this first equation and we're going to use both of our answers. So we said x was 2, so we have 3 times 2 plus 3, and we said y was 3. And we're going to set it equal to 15, and we want to see if this is true. So 3 times 2 is 6, and 3 times 3 is 9. So we have 6 plus 9 is equal to 15, and 6 plus 9 is 15. So you can see here that this does work. Now, you do not have to check both equations. I mean, you should, because you want to make sure that if it works for one, it works for the other. So let's do that. Let's just take that extra step. Let's go that extra mile and let's try it. So you have 2x. We did the 3x plus 3y is 15. Let's do the other one. So now you have 2 times 2 plus 6 times 3 equals 18. 22. So I'm a little ahead of myself here. 2 times 2 is 4, and 6 times 3 is 18. And you ask yourself, well, does 4 plus 18 equal 22? Yes, it does. So you see that the solutions you've come up with for x and y both match these equations to solve your systems of equations by eliminating one variable at first. And if you have any questions, let me know. And I look forward to seeing you in the next video.